The visitor that stopped moving 3 Atlas. A name that now carries more mystery than any comet or asteroid before it. It is currently making its slow, deliberate way through our solar system, and from the moment we first noticed it, we've been watching every flicker, every subtle shift in its path with unblinking attention. There was no precedent for what would happen next. The object, later confirmed to be 3 Atlas, did something no celestial visitor had ever done before. It appeared to stop moving. Discovered on July 1, 2025, by the powerful Wide-Field Atlas Survey telescope system, the object at first seemed perfectly ordinary for an interstellar visitor. A passing comet from another star system, a wanderer on a one-way journey through our neighborhood. Its orbit was clearly hyperbolic, its speed enormous, its trajectory unmistakably interstellar. All data pointed to a simple truth: it was not bound to our sun and would simply glide through, never to return. But then something extraordinary began to happen. As the months passed, as 3 Atlas made its close approach to Mars and curved toward the Sun, astronomers began noticing subtle inconsistencies. The object's motion, detectable, predictable, meticulously mapped, started to flatten out. At first, it was a whisper in the data. A slight hesitation in the expected curve. The rate of motion across the background stars slowed, a little more than our models allowed. Soon, it became undeniable. Night after night, the predicted positions diverged from the observed ones. Tiny differences, yes, but statistically impossible to ignore. Measurement error? No, every telescope, every tracking system, every astrometric calibration checked out flawlessly. And then came the moment that silenced entire control rooms. The motion simply stopped. The object, this massive body from another world, appeared, for all intents and purposes, motionless. It happened just as it neared perihelion, its closest approach to the Sun. Ironically, this was the moment it should have been moving the fastest. Gravity should have pulled it harder, accelerating its flight, curving its trajectory in that classic dance all comets obey. But not this one. Instead, the readings flattened. Velocity dropped. The predicted acceleration curve dissolved into a straight line. Some described it as if a cosmic vehicle had simply stopped in mid-flight, a spacecraft pausing on its own terms, ignoring the pull of the universe. Astronomers were baffled. They tested every natural explanation: outgassing, jetting effects, brightness variations, dust eruptions. None could account for what they saw. A comet's jets usually act like tiny thrusters, pushing and spinning the nucleus as ice sublimates in the heat of the sun. But in 3 Atlas, those jets seemed to cancel one another perfectly. The net result: no motion. Telescopes worldwide, including the James Webb Space Telescope, confirmed activity: a rich carbon dioxide-dominated coma, traces of water vapor, dust grains swirling around a brightened core. Yet none of that translated into expected movement. In control rooms from Hawaii to Chile to NASA's Jet Propulsion Laboratory, scientists stared at data that defied physics. Emails flew at midnight, charts flickered with residuals that refused to balance, and models crumbled under the weight of contradiction. It was as if gravity itself had met an equal and opposite force. An invisible hand balancing the pull of the sun, holding 3 Atlas in a strange cosmic equilibrium. Was the object denser than expected? Heavier? Could its mass and inertia be so enormous that even the sun's pull barely nudged it? Calculations soon revised its estimated diameter upward, from half a kilometer to possibly over 5 kilometers across. A giant among interstellar travelers. Yet that size only deepened the mystery. Why were the expected forces so faint? Why was this body, so massive, so active, so perfectly still? As October 29, 2025, approached, its closest pass near the Sun, the world's observatories turned every eye toward it. They expected a burst of light, a magnificent tail, a surge of velocity as the heat peaked. Instead, the graphs flattened again. Angular velocity, minimal. Brightness, steady. Deviation from models, constant. 3 Atlas had paused. Not stopped entirely, but coasting, hovering in balance, as though waiting for something. And in that stillness, the universe seemed to hold its breath. The implications of stillness the moment 3 Atlas appeared to stop moving, a chain reaction of questions exploded across the scientific world. If a comet could behave like this, defying motion, neutralizing acceleration, what did that say about the physics we believed to be universal? Teams began rewriting orbital models in real time. They added new terms: unmodeled acceleration, momentum drift anomaly, force perturbation. Nothing fit. Perhaps, some thought, the object's internal structure had shifted, a collapse of cavities, a crust sealing over the volatile ices, choking off sublimation and halting the jets that drive motion. Or perhaps, this was something entirely new. A balance of opposing forces we had never before seen. Gravity pulling inward, outgassing pushing outward, and the two reaching perfect, eerie equilibrium. Whatever the cause, the effect was profound. If 3 Atlas could pause, so could others. It meant our assumptions about all interstellar visitors might be incomplete. Maybe not all comets are volatile, explosive, or short-lived. Some could be ancient relics, dense, crusted over, so inert that even the sun's heat can't wake them. Silent travelers that slip through the solar system unnoticed. That realization shook astronomy to its core. Our entire understanding of detection, motion, and classification is built on activity, brightness, jets, tails, acceleration. But what if stillness itself is a clue? 3 Atlas forced scientists to think differently. It may have been far older than our Sun, billions of years old, born in another star system, forged in extreme cold, and flung into the galaxy after its parent stars died. Imagine that. A relic from before the Earth existed, drifting for eons through interstellar darkness, arriving here only to stand perfectly still. Its chemical composition, a carbon dioxide-heavy coma, high dust-to-water ratio, refractory material dominance, suggests it formed far beyond the frost line, in a place where sunlight never reached. That means it might represent an entirely different type of cosmic body, part comet, part asteroid, part fossil of another world. For NASA, ESA, and observatories worldwide, the event wasn't just puzzling, it was humbling. Every system used to predict comet motion, every assumption about solar heating and momentum, had to be questioned. 3 Atlas became a living, or perhaps frozen, lesson in scientific humility. It showed that the cosmos doesn't have to follow our rules. It also reshaped future mission planning. If a spacecraft were ever sent to intercept such an object, and that object suddenly stopped accelerating, the entire trajectory prediction would fail. Missions must now prepare for behavioral uncertainty, the risk that interstellar objects can simply pause in their paths. Beyond the technical, the philosophical impact was even greater. 3 Atlas reminded us that stillness is not absence. Sometimes, silence and motionlessness are forms of communication. Perhaps equilibrium is not failure, but a sign of balance so perfect we can barely comprehend it. In classrooms and observatories, students and scientists now study that pause in motion, the moment when physics itself seemed to hesitate. It is a story of discovery, disbelief, and awe. Because in that stillness, the universe whispered something profound. That even in endless motion, there can exist moments of absolute balance. Moments when time itself seems to hold its breath. 3 Atlas, the interstellar visitor that refused to move, has become not just a mystery, but a mirror reflecting our own limits. A reminder that the universe is still writing its story, and we are only beginning to read it.